We're going to look at applied problems today. Applied problems are basically word problems, but for the most part, these word problems all deal with right triangles. For the most part, if you're not given a diagram, you're going to go ahead and draw yourself a diagram. Typically, these are all going to be right triangles, so you're going to just draw a right triangle for each one of these. We're going to be looking at non-right triangle problems once we get to Chapter 8. Now, for the most part, when we're looking at these, capital letters will be denoting your angles in your triangle. Typically, angle C is the right angle, and your lowercase letters are the sides opposite these letters. So, side C would be opposite your right angle of C, so side C is your hypotenuse. Side B would be opposite angle B, and so on. Sometimes your book will also use Greek letters. Here you have alpha, that's just like your A, or beta is just like your B, and so on. Here we need to go ahead and solve this triangle. Well, the first thing you want to do is draw a triangle. So that's what I drew here. It's going to be a right triangle. We know once again that C is going to be the hypotenuse, so I put my hypotenuse as being 8. A is just going to be one of those other sides. So with everything labeled on our triangle then, we can then go ahead and solve it. So suppose we wanted to figure out angle B first. Well, with angle B here, we would know the adjacent side and we would know the hypotenuse. So let's go ahead, since we know SOHCAHTOA, and use cosine, because cosine is your adjacent over your hypotenuse. So go to cosine of B equals your adjacent side over your hypotenuse. Well, that ends up reducing down to just the cosine of B equaling a root 3 over 2. Well, that's one you're supposed to have memorized, and so you should remember that that is 30 degrees. Well, if B is 30 degrees, and you know that's your right angle, you should be able to figure out A, so A ends up being 60 degrees. Well, with that in mind, let's go ahead and go the sine of our 30 degrees, because we had just said that B is your 30 degrees here. And let's look at this. We want to find B, but we know our hypotenuse, and we know our angle. So that's why I'm choosing to use sine. Sine of 30 degrees is opposite over our hypotenuse. Sine of 30 degrees, you should remember, is 1/2, so you get 1/2 is equal to B over 8. When you solve that, you end up getting B to be 4. Here's another triangle. You're supposed to solve it, so you want to find all your missing parts, all the angles and your sides. So once again, you want to draw yourself a triangle. It's going to be a right triangle. Remember that side A here is always going to be opposite angle A, or alpha for this particular case. Then B just has to be the other right or acute angle in a right triangle. So let's go ahead and find C. If we find C, we have our angle, we have the opposite side, and C is your hypotenuse. Well, opposite and hypotenuse is sine. So let's go to sine of our angle equals our opposite side over our hypotenuse, which is C. You then want to go ahead and solve this for C. And we get this. Keep in mind that what we have here is really a fraction over a fraction equal to a fraction, so you can cross multiply and then finish solving it for C. When you type this into your calculator then, we would get approximately 985. Make sure you're using the degree and minute symbol from your angle function on your calculator, which is second apps. Well, let's go ahead and look at tangent. Tangent would allow us to work with our angle, our opposite side, and our adjacent side. So when we fill that in, we get tangent of our angle equals our opposite of 510 over b. Once again, it ends up being a fraction equal to a fraction, so you can cross multiply and finish solving it for b. When we do that, we end up getting this. Well, we know that this is a 90-degree angle. So then all three of these angles then have to add up to 180. So B then really is just 180 minus those, or if you think of 180 minus this 90, the two smaller angles have to add up to 90. So B is really just 90 minus your initial angle, gives us this angle right here. And you could use your calculator with that if you don't want to do it in your head. For this particular one, you need to find A in terms of alpha and beta. So I'm going to just go ahead and draw myself a triangle. We know that alpha is always opposite side A. And then if that's alpha, this could be beta then, because alpha and beta are always the acute angles. And then side B would be over here. You got to think, okay, what relates my angle to the opposite side and the adjacent side? Well, to do that, we could use tangent, because tangent deals with opposite and adjacent. So we'll go tangent equals our opposite, tangent of our angle equals our opposite side of A over our adjacent side of B. They want us to solve it for A. It says A in terms of alphas and betas. In other words, they want us to solve this for A and just have the other side have alphas and betas in it. Well, to get rid of dividing by your B, you just multiply both sides by B, and we get this. Here we have a spotlight that they're using to measure cloud height. So here's your spotlight shining straight up at a cloud. Then you have an observer over here measuring the angle of elevation to get to that. Well, we're d units away. We need to go ahead and express h. That means they want us to solve something for h. We have our angle, we have this side, and we have this side. Once again, that's opposite and adjacent. So that's going to be tangent. So we go tangent of our angle equals our opposite side over our adjacent side. Then it says express h in terms of d and alpha, meaning get h by itself. So to get rid of multiplying or dividing by the d, multiply both sides by d, and we get h is equal to d tangent of alpha. The very next part says if d is 1,000 meters and alpha is 59 degrees, what is h? They want to know how high the clouds are. So go ahead and plug that in. There's h. Plug in your 1,000 for d. Plug in your angle there. Type that into your calculator. And we get approximately 1,664.3 meters.